Okay, everybody, welcome back from lunch and ready to kick into our next presentation from Arijit Paul, who works in cybersecurity professional. He works in cloud security and lots of threat hunting and incident response. This will be a talk about threat hunting in AWS cloud with logs with Microsoft Sentinel. And a demo tag. That sounds interesting. It's going to be fun. All right, I'll leave it over to you. Away you go.
Good afternoon, everyone. Firstly, I want to thank the B-Sides Sydney team for giving me the opportunity to come and present here. So today's talk is going to be on threat hunting AWS CloudTrail logs with Sentinel. I'm going to show a demo and then how you can uh, hunt and create potential detection opportunities using KQL. So who am I? So I'm Arijit, and I'm a senior cybersecurity consultant at Microsoft. Currently helping enterprise customers with detection engineering, threat hunting, and automation. So today's agenda will briefly touch upon some of the challenges with cloud security, uh, talk briefly about AWS CloudTrail and what it entails, how we can connect Microsoft Sentinel to AWS, and then I'll walk through a demo of an S3 cloud breach attack, which is something similar which happened with a large enterprise customer in the US. And then we'll walk through some KQL stuff on how to build detection rules. And I'll keep a few minutes towards the end for some Q&A. So yeah, feel free to ask questions towards the end. So what are some of the challenges with cloud security? Enterprise customers, when they're thinking of moving to the public cloud, irrespective of whichever public cloud provider that is, uh, one of the key things is cloud security. That's something which every customer, whether it's an enterprise customer or even a greenfield customer, they will have this as one of the important factors. So some of the challenges is obviously maintaining the visibility of your assets within the public cloud environment. Then misconfigurations. Actually, most of the attacks which we see in public cloud or which we have seen over the years are due to security misconfigurations. And then the last bit is understanding of the shared responsibility model. So for example, like AWS has a shared responsibility model where it talks about security of the cloud versus security in the cloud. So security of the cloud is, AWS will be managing, responsible for the hardware and the infrastructure, underlying infrastructure. Anything above that, including the OS and the applications, that's the responsibility of the customer. So AWS CloudTrail. So what exactly is AWS CloudTrail? So AWS CloudTrail is one of the most important services in AWS, which enables you to help out with operational and risk auditing, compliance, and governance. So essentially, any API call, and in AWS, pretty much everything is an API call. Um, so AWS CloudTrail logs all API calls and some non-API calls as well, like console login is a non-API call. Whether it's made by a human entity like a IAM user or a role, or a non-human entity like a service role, everything is logged in AWS CloudTrail. So analyzing AWS CloudTrail logs will help you to uncover any potential security breaches or misconfigurations, any potential attacks. So as of now, I think there are more than 235 plus services which are supported by AWS CloudTrail. This slide is slightly old. It could be more. I don't really know the exact count, but last time I saw it's more than 235 plus services which is supported. So what can you answer from a AWS CloudTrail event? And we'll touch upon, and I'll show you a sample CloudTrail event shortly. But what you can uncover is who made the API call. Whether it's a IAM user role which was the entity which made the call. When was the API call made? So date and time. What was the API call? So for example, console login, even though it's a non-API, but if you're starting an instance or stopping an instance, so stop instance is an API call. Which resources were acted upon? So, what's the EC2 instance ID? What's the region and so on? And where was the API call made from and made to? So the user agent and the source IP address. So user agent could be a browser like a Mozilla Firefox, or it can also be a CLI, SDK, whatever it is. So understanding the AWS CloudTrail schema. So these are the 4 ones which you see in orange are supports nested JSON schema. So user identity, request parameters, response elements, and additional event data. So user identity, obviously, who information about the user that made the request. User agent is, like I mentioned, whether it's a CLI or browser. If there are failed API, there will be an error message generated with the error code. Then the request is, so for example, if you start an EC2 instance, so there will be a request parameter like what's the instance ID, and it will vary based on the API actions. And the response. So if it's a list get describe, it will be there won't be any response element, but anything other than that, like create, update, delete, attach, detach. So you will be able to see successful API response. So what does an AWS CloudTrail event look like? So I'll show you on the console, as that will be easier. So take a look at one of these events. So this event is authorized a security group ingress, and we can clearly see who made that call, when was the call made, the date and time, what was the event source, what was the event name, what's the region of the security group, what is the security group ID. Like every resource in AWS has a unique ID, so like security group ID, EC2 instance ID, and so on. What was the security group ingress rule, all the elements like the request parameters, and then the subsequent response. Like in this case, it was successful response. So essentially, you can find everything. So anything which is done in your AWS environment, you'll be able to track that through AWS CloudTrail. So how do we connect Microsoft Sentinel to AWS? So before that, so Microsoft Sentinel, as we know, is a cloud native seaman source service. So essentially, it allows you to collect your logs, detect your logs, analyze, investigate. So you can do all of this, and also you can build automation on top of it. That's where the SOAR element comes into the picture. So I'll briefly touch upon the architecture, but there is the public documentation on how you can integrate. So currently, these are the 4 log sources which are supported. So CloudTrail, CloudWatch, GuardDuty, and VPC flow logs. These are the 4 log sources which you can ingest to Sentinel. So essentially, the architectures, you have all the AWS services. So you can configure the AWS services, like for example, CloudTrail, to stream it to S3 bucket. And then you can configure event notification on S3 bucket to an SQS queue, which is a simple queuing service. And as soon as there is an event, the event gets stored on the S3 bucket. There will be a notification to SQS queue. The notification will have the path of the S3 bucket where the log file is. And Microsoft Sentinel, how you connect to AWS is using an IAM role, and that IAM role is trusted by a web identity provider, in this case, which is Entra ID, using OIDC as the authentication mechanism. So essentially what it does, it will poll for new messages. As soon as there is a new message in SQS queue, Sentinel will be able to get that information, and that will have the path of the S3 bucket. And the IAM role which you create on the AWS side, it will have the necessary permissions like S3, read-only access, and so on. So I'll walk through an S3 cloud breach attack simulation. So this attack essentially is replicates the attack which happened in 2019 with Capital One, where it affected more than 250 million and 100 million users were affected. So sensitive information, PII information, were retrieved by the attacker, the threat actor, and affecting. They were able to exfiltrate information like credit card data, personal email addresses, and so on. So before I go into the demo, briefly walking through the breach. So essentially, the attacker was able to get hold of a public-facing EC2 instance or a virtual machine, which was a web application server. And so essentially, it was acting as a reverse proxy, and it was not configured correctly. So, and through the reverse proxy, the attacker was able to access the instance metadata service, and I'll explain further when I walk through the demo. And through the instance metadata service, it was able to get the IAM credentials. And so the credentials of the IAM role, and that IAM role had full permissions to S3. So essentially S3 full access. And the S3 bucket, one of the S3 buckets had PII information, which the attacker was able to exfiltrate and fetch the data. So I've mapped it with the, on the right side, you can see I mapped it with the MITRE attacks techniques. So essentially here, you can say there were like 3 entry points. So obviously there was a misconfigured reverse proxy, public facing. And then the second one was obviously the IAM role, which is attached to the instance that had S3 full access. So that was, didn't follow the principle of least privilege. And the third one was from the S3 bucket, data was exfiltrated out. There weren't any alarms generated or triggered. So this is essentially what happened in the data breach. So I have just kind of simulated this environment. So essentially what happened is, so this is the public facing server which you can imagine acting as a public facing server. So essentially what the attacker did is use a custom host header. So host header, as you know, is acts like where an HTTP client is able to talk to the HTTP server. But with a custom host header, uh, what you can do is you can kind of trick that you're accessing you're able to get information about the website without even accessing the actual host. So in this case, 169.254 or 169.254 is the instance metadata service, which is a web service which only EC2 instances or virtual machines have access to. So this web service or IMDS, it allows the users and the applications to be able to get a lot of information. For example, what's the instance ID, what sort of image is being used, what's the host name, what's the IAM role attached, and so on, and other details. So if I just access this and using the host header, so one of them is latest, and then if I access latest, I can get like one of them is metadata, and if I access metadata, I can find IAM, and under IAM there is the security credentials. And under security credentials, you can find what sort of role is attached. So essentially, IAM, you can attach IAM roles to EC2 instances or virtual machines, which are called as instance profiles. So what it means is the EC2 instance is able to assume that IAM role and make API calls based on the permissions which are attached, which are assigned to that IAM role. So instance profiles can only be used by the instance and not a human entity. So in this case, this IAM role had S3 full access. So it was not even restricting to which S3 bucket. It was essentially S3 star to all resources to star. And when I access the role, I'm able to get the access key, secret key, and token. So essentially, in IAM roles, one important difference between IAM user and IAM roles is, so IAM users are long-lived credentials. So essentially, persistent access. Unless you rotate your access keys and secret keys, they are long-lived credentials. But IAM roles are a short-lived credentials. So it uses the STS service, the security token service. So so if you see the short, the it says when it's supposed to expire. Um, so essentially, it's a short token service, and you get the access key, secret key, and the token. And what you can do, you can configure a CLI profile and basically use those credentials, the credentials from the IAM role or the instance profile. So you provide the access key, secret key, and then you can update your credentials file and add the security, the token. And then using that profile, I'm just doing a list of the S3 bucket. So you can get all the, so these are all the S3 buckets which are there in my environment. And then if I go further into the specific bucket, S3 bucket, I can get all these files, which are called as objects in S3. And then I can just do a sync, which is essentially I'm downloading the objects to my local directory. So this is how you can exfiltrate using the IMDS service using a custom host header. And this was back in the day when it was using IMDS V1. You didn't even have the option of using IMDS V2. Just going back to my demo. So how can you threat hunt with Microsoft Sentinel? So essentially, the idea is how can you build potential detection opportunities to proactively threaten for, to prevent future attacks. So what are the things we look for in a threat hunting scenario, especially if you want to proactively threat hunt? So obviously you have different alerts from detection services. In this case, you have the CloudTrail logs, which are ingesting to SIEM, and then you have guard duty. So AWS guard duty is a threat detection service. So you can even send those guard duty logs to Sentinel, which I touched upon earlier. So you can look for all API activities. Obviously, with CloudTrail, you can find that information. Especially look for API actions which makes modifications. So all your create, update, delete, attach, detach, and so on. Look for user agents. What sort of user agents? What sort of source IP addresses? Anomalous source IP addresses. And then you can drill down on the specific API actions. So for example, EC2 instance is turned, or if you observe like large EC2 instance types, like let's say M4.10x large, that should trigger there's something wrong going on. Or if you observe a large volume of data being exfiltrated out from an S3 bucket. So these are things which you can proactively build detection rules. So I'll go through some of these in my KQL environment, my Sentinel environment. So I already have configured AWS. I'm getting the AWS logs ingested to Sentinel. So using the connector. So in Sentinel, you have a connector available for AWS. So you need to set that connector. So as I've discussed, you have the AWS side and where you create the IAM role with the permissions, and you also have the the Sentinel side or the Microsoft side of things, where you need to create this connector. The connector is readily available through Content Hub. You install that and you need to configure this. So as you can see, currently I'm only getting ingesting the CloudTrail logs. And so you can see this is the name of, this is the ARN of the role. So the Amazon resource name, and this is the SQSQ URL, and that's the table, the CloudTrail table. Uh, just to briefly show you, this is the SQSQ which I have, and you can see the IAM role. Essentially, this is the IAM role which I have, which has the necessary permissions like S3 read-only access, SQS read-only, and that's the S3 bucket. So if you are ingesting multiple logs, like let's say CloudTrail, Guard Duty, VPC flow logs, and CloudWatch, so you can use one bucket, but you need to have separate folders. So, so for example, if in this case, um, so I'm getting only CloudTrail, but if you want different logs, you need to have separate folders in the same bucket, or you can even create a separate buckets altogether. So you can have like 4 buckets for 4 log sources, or one bucket but different folders or different objects under that. And obviously this is the CloudTrail trail which I have configured. So coming back to the queries in KQL. So KQL, Kusto Query Language, as you know, is it's Microsoft's query language, which allows you to um, analyze log sets, large data sets. So you can ingest different log sources, and you can ingest it to Sentinel, which is powered by Log Analytics Workspace. And then you can run KQL, which is Kusto Query Language, to analyze these large data sets. So AWS CloudTrail is the name of the table. So the easiest way or the best way to get started is to look into the schema of any table. So for example, you're ingesting AWS Guard Duty logs. You can look into the schema by just typing the table name and then get schema. So essentially, these are all the columns which are supported, and they typically mimic what you see in the CloudTrail event, which I showed earlier. So you can go further by looking into, let's say, by event source. So if you want to see last 24 hours, what is the count, which service is generating most number of events. So you can see here like S3, C2, and so on. You can even do count by IP address. So which is the IP address which is generating. Then you can summarize through user agent, which I discussed earlier. You can even summarize by multiple column names like event source, event name, event type name. So for example, you can see here, I have put object. Put object is essentially you're writing something on the on the bucket. Get object is you're retrieving. This is one example of a simple query where I'm checking console login, and I'm detecting whether MFA was used or not. I'm looking to the last 30 days worth of data. So if I just run this, so essentially it's showing that I had console login done by an IAM user. MFA was used, and there were like 3 times. And for a role, there wasn't MFA used, but there were like 17 attempts of 17 console login events being generated over the past 30 days. One easy way to search across your data for anything like an IP address or a host name is to just do a search. So in this case, this is my threat attacker IP address, public IP address. I'm searching and I'm checking if there are any hits on any table in Sentinel. So I can see that there is AWS CloudTrail, which has like 9 results. So I drill down even further because I'm interested only in the AWS CloudTrail table. So I can see these are all the API calls, and these are all the results which I'm able to see. So if I filter just for that specific event, in this case, get object, so I can look further. Before explaining this, just one thing to keep in mind. So by default, when you set up a CloudTrail trail, the default is only management events. So in this case, if you want to see object level operations, what is being done on that object, so whether someone is downloading or retrieving the object, or writing to the object, to that particular S3 bucket, you need to enable data events for S3. If you don't do that, you won't be able to see object level operations. You will only see management level operations. So that's something which is recommended if you want to analyze and detect object level operations in S3, and even for some other services. So for example, if I want to dig deeper into this event or that API call, you can look further. You can see that the API call was get object. It's an assume role, which instance was responsible, and what's the user identity ARN. So it's an assume role. This is the name of the role, and this is the name of the resource, because this role was attached to this resource, essentially an instance profile. When was that API call made? Then what was the region? Then you can look into the request parameters. Also, you can see what's the user agent, then what's the request parameters. In this case, it's a get object. So I was looking into the one of the S3 buckets, and this was the file name. So I was doing a get object. And you can actually drill down into the additional event data, and you can see how many bytes were exfiltrated out. So bytes transferred out. So some of the potential detection rules which you can proactively create, just simulating this environment. So one of them is look for any privileged role which are attached to instances. So for example, so AWS has policies which like are by default created. Obviously, you can create your own custom policies, but these are some of the default privileged policies. So you can essentially hunt for if any role has this privileged policy, any one of the privileged policies attached. So you can look into it. You can try to do a comparison. So for example, I can see that I have one resource, one role which has this policy present. This is the role. Then the next one is to look for STS API assume role operations. So essentially, you want to see any history of assume role operations being done. So in this case, I can see that it was done by ec2.amazon. So EC2 was the resource. And you can look further into this was the role which was assuming, this role was being assumed essentially by EC2. So you can drill that down further. Then you can look into suspicious data access from unknown IP. So if you observe an anomalous IP address be accessing an S3 bucket, which you have not observed earlier, for things like list objects, get object, you can add your own event names as well. You can filter down. So for example, you can see here, I'm seeing two anomalous IP addresses which hadn't accessed this bucket earlier. Then one good one is data transfer anomaly. So what this does is I'm using KQL's built-in anomaly detection algorithm to check for any deviations in the baseline pattern. So for example, if I run this, so if I look into the chart, I can see that on this particular date, Yeah, same as connect. Sorry, can I? Yeah. 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 No, I'm almost done. Yeah. No, it's okay. I'm almost done. Okay. Um, I'm almost close to the end of my session, so it's like I'll take probably 5 minutes. Uh, so yeah, so essentially, you can see that on these two particular days, there were large bytes of data exfiltrated out from the S3 bucket. So that's something you can potentially convert it into a detection rule. Then one good one, at least now, is you can look into the IMDS version. So currently AWS supports both IMDS V1 and V2. It's recommended to use V2 for obviously security best practices, because IMDS V2 prevents SSRF attacks. It's only up to maximum of 6 hours. The session can only be up to maximum of 6 hours, and a lot of additional benefits which it offers. So you can look into the IMDS version. So essentially, if IMDS version is required, it means only IMDS V2 is supported. V1 won't be supported on that instance. If it's not required, it means optional, then both IMDS V1 and V2 is supported on that instance. Then the other one is get caller identity. So what I'm doing is I'm first grabbing the instance ID, and then I'm looking at get caller identity. Get caller identity is when you are accessing the IMDS from an EC2 instance. So which I showed this earlier. So essentially, you're retrieving the credentials from your EC2 instance when I'm accessing the IMDS. So that's when your get caller identity is called. And last one is just to look into any suspicious creation of resource or suspicious API calls which you want to investigate and want to monitor. You can do that. You can add your own API calls like stop instance or create security group and so on. So these are some of the potential KQL rules which you can convert it into detection opportunities. So just to wrap up, these are essentially the screenshots. To conclude the threat hunting scenario, this is the flow chart, and you can see the entity types, so which you can monitor. So in this case, the attacker IP, obviously anomalous IP, a good thing to monitor. Um, Again, if you are using guard duty, a lot of it will be generated automatically, a guard duty finding, because guard duty supports like more than 150 finding types. But if you're just using CloudTrail, you can analyze it, but you just have to make your own detection rules and monitor these APIs. CC2 instance, run instances, I told you, you can look for IMDS versions. Then get caller identity, which is a very important API to monitor, where you're accessing the IMDS to obtain credentials. For IAM roles, you can look into where if you have any critical policies which are attached to your IAM roles. S3 bucket, obviously, get object is one important event, especially if you are observing large bytes of data being exfiltrated out. And similarly for S3 files. All right. Thank you. Happy to take some questions.
Okay. Thank you for that. It was very nice and technical, which was good. That's from us here at B-Sides, little present for you. Actually got a question for you. Assuming that, because nobody else had a question, that's what happens when you don't ask questions. Assuming that all that information is able to be turned into a visualization, so you could easily see all those reports instead of just seeing the logs. So alerting, like a scene type thing.
Yeah.
Yeah.
This is all
Awesome.
in a scene. Yeah.
Oh, there you go. That's what happens. Yeah. Yeah. Sorry. Finish your answer first.
Yeah. Sorry.
Yeah. Did you have any more to add to that or not? It was just yes or?
Yeah, you can do that because what I was showing is in a seam. So Sentinel,
it is a scene.
Yeah, it's a scene.
Okay.
So
it has alerting capabilities and it will send an email.
Exactly. Yeah.
Alert. All right. No worries.
Okay. So with CloudTrail, you were showing that the data exfil was happening. Can you actually see the files that went out? Can you see the names that were taken out? So when you had the mass amount of data, so you can actually see, like, let's say they took, first name dot last name dot text. Would that show up in the logs?
No, not the underlying information about the file, but the file names, you will be able to figure that out.
The file names would be, but yeah, I mean, like the dot text files, you'll see the name.
.x file.
Okay, cool.
Yeah, or .csv or whatever. Yeah.
Else? Last chance. No. All right. Oh, see, 2 at a time. Look at that.
Yeah, cloud logs usually bring a lot of data into the platform. So the question is about how to save a bit in terms of money. So what are the filtering opportunities? What data do you recommend to filter out? Like, for example, KMS, right? There's a lot of things, especially when you use your own key material, then every request produces like dozens of useless, log records. What are the filtering opportunities there?
So it depends on what type of data. So for example, like I showed you for S3, IAM, there are a lot of these event types which you would like to monitor and you want to filter out. But if you are looking for like read operations, you can probably might not more like to monitor, but especially any CRUD operations like creating or updating, deleting, detaching, you would like to monitor, like you mentioned for KMS. So yeah, those are things which you would like to monitor.
No, how to filter them out so we don't have significant cost on the Sentinel side? Is there a way we can parse and filter at the connector level?
Oh yeah. No, not at the connector level. So when you're creating the queries, the detection rules, you can filter out a lot of that stuff like exclusions.
Trying to figure out a way to filter before it enters Sentinel, because Sentinel's super expensive.
Yeah.
So we all want to find solutions for security that's affordable and things. So is there a way we can filter or pass logs at the connector level before it reaches Log Analytics Workstation? So then we can only query on the fields we need, like the additional nested fields, timestamps, etc., but omit the rest?
So 2 ways. One is you can't do on the Sentinel side, you have to do on the source side. So for example, if you don't want particular type of events, like you only want management events or some other events, you can do only on the CloudTrail. Same with Guard Duty. Or there's a separate product called Cribble. Cribble helps you to stream from one log source to the other. So it can act as an intermediary. You can do a lot of modification on that side. You can even not use a Sentinel connector at all. You can use Cribble to ingest logs from the source to essentially AWS to Sentinel. Yeah.
Do you still see customers using IMDS v1? I mean, the attack should be stopped by using IMDS v2, right?
Some of the older OS still use IMDS v1. Like if you're using let's say Ubuntu from 2023 or 2022, they're still on IMDS v1. Also, it's not just the OS or the like CLI, Amazon AWS CLI and all. A lot of your applications also need to support IMDS v2. So yeah, but the newer OS like Amazon Linux 2 2024 onwards, or even 2023, they are by default IMDS v2. So you can't even, like, it's by default, it's using IMDS v2.
Any more questions?
Yep. So thanks for the talk. I can see like you cover all, like mostly all the AWS entity. But just a quick question, because I did some security testing as well, and I found there's one of the entity called SSM where you can actually do privilege escalation and run any of the command at root. So do you like, does the Sentinel still cover that as well, or just like all the entity that you list in the slide?
No, it does everything. So whatever you're there in CloudTrail, so essentially Sentinel is whatever data is ingesting to Sentinel from, let's say, CloudTrail or Guard Duty, whatever you ingest, everything can be monitored. Doesn't matter which particular service, as long as you are ingesting whatever log sources, because Sentinel is able to fetch the information from the S3 bucket. So whatever is hitting the S3 bucket, whether it's so CloudTrail, obviously it monitors every single API call, like I mentioned, from pretty much most of the services. So yeah, SSM is also supported. Yeah.
Okay, thank you.
I wanted to add on the two questions from the two white shirts. So to detect suspicious behavior coming from the AWS trail, how do you make our analysts monitor all of that without just looking at pure logs? So, because you said, yes, it can be turned into an alert, but in Sentinel, how do you do that? How do you make it into an alert, and what would the alert be called? What are we looking for?
So when you set up the Sentinel connector, the connector by default has a lot of out-of-the-box rules. These are called analytic rules or detection rules, whatever you want to call. So you can use a lot of that, but the customers like I work with, they use custom rules as well, depending on their own use cases and depending on what sort of services they're using. So you create your own rules. Essentially, the rule is nothing but a KQL query, and you just make it into an analytic rule, and then you monitor that. And if you do some testing, see the results for last 14 days, and you can exclude a lot of false positives, like if these are supposed to happen or it's can be ignored, then you tune that. You can modify that query essentially, and then you start getting the alerts and incidents. Yeah.
That's pretty good. So you just make analytical rules.
Yes, analytical
using
rules
KQL, and it will trigger if it
exactly.
is successful. Yeah, that's pretty good. Thank you.